hello, Nordconf Argentina. Well, bienvenidos, and that's literally the only Spanish you're gonna hear from me today. Yeah, so let's see if this works. There you go. So this is me, Istvan Smozsansky, and you'll be relieved to know that you can just call me Flaki, so you don't have to deal with all those accents. This is my dear co-presenter Bela, and we're going to be talking about oops, come on, there you go. We're going to be talking about the JavaScript Singularity. So I have a slight story to tell about this. I have given a subtitle to the talk, and that's "Okay, but why should I care?" And last week, I was in Munich. I was in Munich.js, and I pinged the organizers of Munich.js, hey, I have this talk happening. It's a brand new talk for Nordconf Argentina. I really want to test drive it, so can I give it to you at your meetup? They were like, yeah, oh, this sounds amazing, Singularity and shit. Yes, please do. So I give the talk. It feels right. It's a bit too long. I was like, oh, I'm not going to fit in to the 30 minutes. So, well, I'll figure it out. So we go on, and Nordconf Argentina releases the schedule 2 days ago. And I look up all the speakers that are speaking today, and we've been speaking about parallelization and Node.js and NAPI and chatbots and chirp, and then I was like, wait a second. That's like 90% of the topics I wanted to talk about. Uh-oh. And, you start thinking, and that's why, oh, that's not bad. So I can actually just refer back to all the speakers. And you will already know it, because you've been here, you weren't sleeping, you weren't sleep deprived, you weren't like hanging out outside. So you'll know everything, so I don't have to talk about this stuff. You will know all this amazingness that happened, and this was just day one, right? I mean, how cool is that? How mind-blowing automated curtains and like plants talking to each other, all those things you already, you've been presented. And now you know why this is called, okay, but why do I care? So let's dive into and talk about some pain points that you might have had with JavaScript. If you have been developing JavaScript or Node.js, or both, you might have come across an issue of JavaScript performance. JavaScript performance is this ethereal thing that, JavaScript was never intended to be fast. And, just an hour ago, Francie was here to tell you that even though JavaScript was never intended to be fast, it was a language developed in like 10 days, and like nobody really knew what this, like 10 years later, we're gonna be running now JavaScript on microcontrollers, and like it's gonna be powering spacesuits and all those crap. It eventually became fast. And the reason it became fast and the method it became fast was exactly like what Francie described it. About 10 years ago, JavaScript was always an interpreted language, and browser makers and JavaScript engine makers figured out how to make it fast. They will just make this dynamic language. They will just have a very good look into all the functions, all the things that you're running, and they're going to figure out how to make that dynamic language a static language. They will just use a JIT, an optimizing compiler, and in 2018, you can see the graph like explode. And the thing is, JavaScript exploded, performance exploded, like V8 was followed by all the other browser vendors. A new performance war raged all across the browser vendors because everybody wanted to have a fast JavaScript engine. Now the problem was, you got an amazingly fast JavaScript engine, and with that speed, new use cases came. All the use cases, one of them including Node.js. Node.js exists today because V8 was a super fast and kind of easily embeddable JavaScript engine that people could reuse. So people were experimented, and people started working with this, and people figured out that we're going to put JavaScript onto the server side, or the console, or like the native UI, native space, whatever you consider Node.js is today. And it worked. Bunch of new use cases emerged. You use Node.js to serve files. You use Node.js to power Electron, desktop applications, to compile modern JavaScript into old JavaScript and run all kinds of build optimizations. But there is a limit to how fast JavaScript could be. Again, like you know from Francis' talk, we came really close to native speed, but we're still like twice as slow as we could be, as native compiled modules could be. So there were things that you could do. There were some new use cases that you could achieve, but JavaScript was not fast enough to run complete 3D games in the browser. JavaScript was not fast enough to generate code that was able to run a complete multimedia 3D experience in the browser. This was just one of the things JavaScript was still not able to do. And eventually, there were experiments at SMJS and various other means to make sure that JavaScript eventually conquered these use cases. But when JavaScript conquered these use cases, other problems and issues emerged. Other issues like, oh, now we are compiling a complete game engine, which is like 100 megabytes into like some shady JavaScript code that has like a funny look to it. You still have to pump that 100 megabytes of JavaScript through the network. That's not fun. But you know what's not even less fun? The browser engine has to go in and try to interpret that whole jungle of JavaScript code that you just sent them. JavaScript parsing is super slow. So no matter how optimized and fast JavaScript engines became, people were yearning for more speed. It's like it's like drugs. If you get some drugs, you want more. If you get some speed, you want more. So this is how the era of WebAssembly enters. And as again, Francis' presentation showed you a glimpse into WebAssembly. WebAssembly can be almost as fast as native compiled code, while actually being tightly integrated into the web platform. And what that means is actually what I really want to talk about. Because this is how WebAssembly looks like. This is not JavaScript. If anybody knows Lisp, I don't see anything. Lisp, shout out. I don't see, so yeah, there you go. Yeah, so on the left-hand side, you can actually see the actual binary format that WebAssembly compiles to. And on the right-hand side, you can see a human-readable, well, depends on which human, a human-readable form of the binary format. The human-readable form is also human-writable form. And you can find people who are handwriting JavaScript, WebAssembly text format for fun and profit. There are those people. I respect them highly. But WebAssembly was not meant to be handwritten. It was meant to be compiled from low-level languages. And why it's important that you compile from low-level languages is it's super simple. JavaScript is a high-level language with all its baggage. It's dynamically typed, it's memory management, it has automatic memory management, and all of those issues make it almost impossible to create highly optimized code, because that's not how the computer works. So what people did when they invented, basically they evolved WebAssembly from the previous experiments, is they did a virtual machine, but a virtual machine is a virtual CPU that basically executes WebAssembly code. Now, the interesting part of this is while Francis' talk would show you how you compile JavaScript code using the JIT compiler and the optimizing compiler into system-specific assembly, so close to the system, close to the metal machine code, WebAssembly actually compiles to a close to the metal machine code, but not of any system specific. It's a virtual CPU, a virtual hardware that you are compiling to. Why is it still worth it? Because it's very close to how computers work today. Not as close that you can just run verbatim on like any CPUs or any actual hardware architecture, but browsers will be able to very easily and quickly translate it to the actual language and the actual hardware that you're running your browser on if you compile your code to WebAssembly. And the important part of using a low-level language is because then you can make use of all the low-level optimizations, types, and everything that you would be expecting to use in a low-level language. This is what makes WebAssembly fast and efficient, but what makes it part of the web platform. WebAssembly was made to power websites and JavaScript pages, and the idea is that you go on, and just as you would go, and Francie would tell you, always optimize when you know what you want to optimize, always find a hot code, never just go on blindly. WebAssembly takes on the exact same thing. WebAssembly is used or expected to be used very discriminately and surgically replacing your code where you really need more performance. JavaScript is a nice language. You can write a lot of things in JavaScript already, and it's going to be reasonably fast. When you really have to turn out like that extra performance, you can turn into WebAssembly and use it for something like parsing parsing files from a mapping file from your JavaScript. So imagine you're compiling your modern JavaScript using Babel into something like a ES5, so older browsers could use it, but you want to debug this file, and you will have a mappings file that will tell the browser when you open the developer tools that your jungle of like minimized and compiled code actually refers to your original source code. These files are big, especially if you're compiling like 2-3 megabyte JavaScript bundles. And Firefox used to have a JavaScript implementation of this parser in the web browser. The Firefox developer console actually runs JavaScript. It actually runs React. The whole user interface you're seeing is React and JavaScript based and HTML and CSS. So if you ever open the Firefox developer tools, you are seeing an HTML UI. Now the important part is that they actually managed to simply replace the JavaScript code that was responsible for parsing source maps and make it 8 times faster. There is a very interesting link on the bottom of the slide. I'm going to share the link to the slide. I implore you to read the Speed Without Wizardry post by Nick Fitzgerald, who is the engineer who worked on this integration, because the source map parser could be used in Firefox, but could also be used in other places. For example, it could be used, and there's an experimental flag that you can use this Rust-compiled WebAssembly source map parser in Webpack today. So you can actually speed up your Webpack code, and there is a presentation just a few days ago. One of the Webpack core team members were telling about how they're integrating WebAssembly into Webpack, but also WebAssembly support for Webpack. So WebAssembly could power entire browser engines and make them faster. And you're like, Francie already mentioned this because WebAssembly is in V8. What would you do if you want to use WebAssembly Node? Well, you can use WebAssembly Node. Okay, I'm doing my Node stuff and I'm compiling something that needs desperately the extra amount of speed that I'm gonna need. So I'm gonna go in Node.js. I'm gonna create a binary module. So if you want speed in Node.js, you're gonna get into trouble because when you want more speed in Node.js, you're gonna see JIP errors. JIP is not perfect, and you have plenty of talks talking about why it's useful, but it is also has its own fair share of problems, because what JIP does is it creates native system-dependent libraries, compiled packages from your Node.js binary modules. So what Node.js does is it builds you a native library so you can use those speed increases, but it also has its own fair share of problems. So what you could do though, instead of using native Node modules, you could actually use WebAssembly today, and there are plenty of libraries that are actually transitioning into using WebAssembly instead of using native compiled modules. This is going to cut down one single WebAssembly module can serve an entire whole ecosystem of Node developers and web developers on the client side. So you won't need all these native compiled modules for simple tasks like generating Sass or SCSS code from your CSS code from your SCSS or Sass sources. There are, though, some caveats, because WebAssembly cannot, sometimes you use binary modules to gain more speed, but sometimes you use WebAssembly modules to gain system access, or even lower level access to the system resources that Node.js provides you by default. So, and this is not a new thing, like this has been going on, this has been a thing for a long time, is dropping down to a lower level of abstraction just to be able to use a system API, a system-provided API closer to the hardware, or just purely for performance reasons. And WebAssembly will help you with the later one, performance improvements you can fix with WebAssembly. But WebAssembly won't be able to fix your system needs and system resources needs. So if you're going to control, if you played with Johnny 5, you're going to need access to serial port in Node.js, and WebAssembly won't be able to give you because it runs in a secure sandbox, just as the JavaScript engine, so it doesn't have more access to the system. What can help you is, again, just the previous talk talked about how you could use the an API that's just landed in Node 10 to create modules that actually use a single ABI, application binary interface, to interact with the Node system. So a lot of the churn from these modules can actually be eliminated in modern times. But you know, we talked about performance and how you can use this modules and that modules in Node.js. Let's talk a bit about code separation. And let's admit it, code separation wasn't always great in JavaScript. Actually, it wasn't never great in JavaScript. This illustration is from Lynn Clark's article. I linked to several of Lynn Clark's articles. She's a principal evangelist on the Mozilla team. She has amazing explanations of WebAssembly and just how the browser works, and like basically all of her explanations are amazing. So you should definitely check those out. The interesting part here is that JavaScript, code separation in JavaScript was always a mess. You have CommonJS on the server side, and you use something like AMD or Require.js, or just basically throwing things onto the global all the time. It wasn't great. And we had the savior ES6 or ES 2005, as some people like to call it, came around, and we were like, we're going to save you from this hell. We're going to give you a module system that works both on the server side and the client side. And that looked promising, but that was like 2005, right? So, and it's 2018. Now, browsers have landed mostly, and for most part, if you are in a modern browser, you will be able to use ES modules just fine. But Node.js, due to having a huge CommonJS ecosystem, had trouble integrating the new API into Node. And okay. The good news here, so I'm not going to go into what ES modules is, but the good news is actually you can now experiment with ES modules on Node 10 as well. The new support for Node 10 landed, oh, wow, sorry. Mic problems, there you go, maybe. Yeah, so the new Node modules support landed in Node 10, that didn't make it better. And now you can actually, you still have to use a experimental flag, but you can use ES modules in Node as well. The interesting part of that is, like, the end goal of this whole thing is to have even WebAssembly integrated into this the whole package to contain WebAssembly as well. So it's not just you could use Node modules in the browser, Node modules in ES modules in the browser, ES modules in Node, and ES. Oh God, this is not great. Maybe. ES modules in Node, ES modules in the browser, but also to make no distinction between using JavaScript code or WebAssembly code in general. Because WebAssembly modules, when everything is said and done and the proposal is already on the way, WebAssembly modules will integrate into the NPM ecosystem. You can already find some WebAssembly modules in the NPM registry, and you'll just be able to use them transparently without having to even know or think whether an NPM module that you just installed contains JavaScript code or WebAssembly code. That gives you unparalleled composition of always using the correct language and always using the correct tool for whatever use case you're trying to achieve. And the whole idea of this talk is, thank you. Perfect, thank you. No, not perfect, but we'll just have to make it work. Let me shift it to the line. Yeah, so not gonna mess around with this. So yeah, together we are more, and what that means is you might remember this guy. JavaScript has this thing about it that's called one JavaScript. There's a more elaborate description on this, but what this basically means is that JavaScript is not to be forked. There is only one JavaScript, and all the ES versions constitute to the same JavaScript. That means there is no forking on the language. The latest ECMAScript specification is always the JavaScript. And every browser vendor, every JavaScript engine, everybody strives to support all those features that are accepted as a standard in JavaScript world. Now, there is an issue with this, and I'm going to get back to that in a moment. But there is also a problem with JavaScript having one thread, and you will know in a moment what that means. The problem with one JavaScript is it only refers to JavaScript. And browser APIs that you use or the Node runtime that you use is so much more than just the JavaScript engine. In V8 and in the JavaScript specification, few things are specified that are part of the core JavaScript language. But no browsers, no JavaScript specification exists, for example, specifying how do you use system resources, how do you use networking, how do you use file system access. All of these APIs are defined separately, either in DOM APIs for the browser or Node APIs in various bindings to the native system. And there's a solution for that, is convergence. There is again, mentioned earlier before, a worker thread proposal for JavaScript. Yeah, thank you. Just if you go on stage, make sure you don't perspire. Sweaty people's faces don't like the mic. So yeah, there is a experimental worker threads landed in Node.js. So Node has also always been one single-threaded. All the operating system compatible APIs were able to provide you with various kind of multi-threading because, but the JavaScript code you were executing was always single-threaded. And so what happens here, you still want to have, especially with a fast JavaScript engine like Node, you will want to be able to execute Node JavaScript code fast in Node.js. So what happened is people wanted to make this easy. And you could do this cluster with the cluster API and all kinds of other things. And there is no web worker threads API that you can use. The interesting part of the worker threads API is that it actually resembles, if not entirely is the same, as the browser API counterpart that provides you web worker access, which was the same problem in browser-based JavaScript. They wanted to have ability to run JavaScript on separate threads to make sure they don't lock up the UI, they make sure they don't lock up the main thread. So the interesting part is that not that you can now run JavaScript in a separate thread in Node.js, but you can do it so using a API, using an interface that is familiar to you if you have used workers in the browser anytime. And this has been a more recurring theme, Node taking some lessons from the browser market and implementing some of those APIs in the browser. Some text conversions API have happened, and even lately there was discussion to having a fetch API to be implemented in Node. There is a discussion on the Node.js, there's a link to that in the slides, and people have, you know, as people always do, people have feelings about implementing the fetch API into Node proper. You can always install an npm package that polyfills that functionality using the HTTP and HTTPS, like the local modules, the networking modules that Node.js already has built in. But people wanted to have this as a convenience. And the important part is, you know, there is a huge amount of value in experimental projects. And this particular comment refers to Dino. You can, Guy Bedford says, in my opinion, there can only be value in considering ideas and insights from any other projects for inspiration in Node. And, you know, the browser, the web platform is quite a bit, you know, quite a successful inspiration in that term. So it definitely makes it worthwhile to take some inspiration from the web platform and re-implement APIs, make it easier for people to write truly isomorphic code across the browser and the different runtimes of the JavaScript platform. Why Guy Bedford refers to Dino, and if you haven't heard of Dino, Dino is this experimental project by Ryan Dahl, announced just a few months ago. That's basically a re-implementation of like the whole Node.js experiment. It runs TypeScript. It has like a Rust backend, and it focuses on security and focuses on browser likeness. So just last week, 2 weeks ago, I was at a conference, and I realized that Dino actually exposes a fetch API. So instead of like creating their own way to interact with the network, they just reused an already well-known API, an already well-known, you know, ergonomic construct. So people who are familiar with browser workings can just write Dino code without, you know, worrying too much about having to look up reference documentation, all of those things. Obviously, it's an experiment. It's not complete in any shape or form, but it's a good idea. And, you know, experimentation is essential to improving the tools that we currently have in the web platform or in the JavaScript world in general. Such an experiment, and I just had a very fulfilling conversations with people working on Electron lately. Electron is such an experiment. Like the real gain from Electron could be, so Electron is this platform that you use Node.js and a built-in browser engine as well. So you can use system APIs in a native-looking application, but still use the browser and browser APIs to display a user interface. Slack and a bunch of other desktop applications are actually Electron apps. And Electron basically came out as an experiment for GitHub's add-on editor. They wanted to create an editor in JavaScript, and Visual Studio Code, for example, is like an improvement or like Microsoft version of the add-on editor. And it was a big experiment. And if you ask me, the main goal of Electron is that you will not need Electron at all. The main goal when Electron, the whole experiment fulfilled its promise, is going to be when all those learnings that could be learned from all these experimentations using Electron are learned and integrated into the web platform, integrated into the JavaScript world. Electron will cease to exist just because you won't need it anymore. And this is the big goal of any experimentation. And I think Node.js has been an experiment for way too long. It is about time that we figure out ways to integrate Node.js and the web platform more tightly coupled, more tightly together. And there are already work going on into this direction. Not because we have feelings about JavaScript, and not because we think how this should work, just because for the sake of our users. JavaScript is an easy to get into language, but it gets hobbled down by all the craft that we add on using all these libraries and all these different API structures. So any way we can make that easier is always going to be a great win. So I have a few more things that I'm never going to have enough time to go into, but if you want to learn more about it, there is a bunch of links about the magical future when all these things that I was talking about actually converge into the actual JavaScript singularity. Currently, we are hoping that we are dancing on the edge of the event horizon or something like that. As a shameless plug, I do hardware stuff with JavaScript. If you want more reasons why you should love JavaScript, you can do hardware stuff with JavaScript. So talk to me about JavaScript hardware stuff. And almost exactly 3 years ago, I was at speaking at NodeConf EU. I was talking about how you could use Rust, the programming language, to generate binary modules. And at some point in my presentation, I told people, eventually you realize that the language itself is just a tool. Whether you write Rust or JavaScript, whether you create WebAssembly code or whether you write PHP or Java, it doesn't matter as long as you choose the correct tool for the correct use case. And the only way you can choose the correct tool if you know that the tool exists. So you are here to learn about the existence of tools that you are going to be able to use. Don't hold on too much to all your preconceptions and all your tools. What would have happened to humanity if we would still be using tools from the Stone Age or Bronze Age? We evolve our tools to fit our new requirements, the new expectations that we expect them. So I hope I've given you a few tools to think about and a few languages. The talk links are above. You can see my Twitter account and must-hacks if you want to follow on cool Mozilla stuff and modern technologies. If you go to, the slides are not online, but will be online on this link. There is a reading list at the bottom at the end of the slide deck. So thank you very much. This was the end of the first day. See you tomorrow.